So today's video is going to focus on conversions. So if you're struggling with conversions, this is the video for you. I want to start with this number one problem. So we'll call this number one. What is the mass of carbon in 1.5 grams of C6H12O6? And so this is what we're looking for, is the mass of carbon. And so I'm going to write it at the end. So we need to find mass of carbon from that information. That's where we want to end. And for the starting information, it tells us that we have 1.5 grams of this C6H12O6. So we're going to start with that. So we start over here with 1.50 grams of C6H12O6. And in order to get from C6H12O6 to carbon, so if we want to compare the carbon in the molecule to the carbon at the end, we always have to be in moles. So we've got to be in moles to get there. And so when I look at this, notice for this compound, so if I have the whole compound, I have 1 mole of C6H12O6. And looking at the formula there, we have 6 carbons. And so that means that for 1 mole of that whole compound, I have 6 moles, rather, of carbon. So that's my conversion factor. But in order to compare those two, notice here, I've got to go from mass to moles. So that first conversion, and this is true for any conversion that's going from mass to moles or moles to mass. So if we go from grams to moles, or from moles to grams, then we're always going to use something called the periodic table. So this is a periodic table conversion. So to get from mass of this compound to moles, I've got to figure out what is the mass of that whole compound. So I go to the periodic table, and I note that there are 6 carbons. And if I look at the mass at the periodic table, I multiply that by 12.01 grams per mole. There are 12 hydrogens, so we have 12 times 1.01 grams per mole. And then we have 6 oxygens, so we would take 6 times 16.00. We'd have to multiply through and add all of those up. So I'm going to do that on my calculator. You can pause the actual video and you can look at that and see if you get the same as I do. And so I end up with 180.16 grams of that compound per mole. And so what that means is that for every 180.16 grams of C6H12O6, I have 1 mole of C6H12O6. So this is a conversion factor that we had to go to the periodic table for. In order to get grams to cancel and get to moles, that means I've got to have whatever's on the top of the fraction. I also need it on the bottom of the fraction to cancel. So I would start by taking this 180.16 of C6H12O6, and it would be put on the bottom. You can understand this 1.50 as being over 1. And so now we've got mass on the top and mass on the bottom. And so that will cancel out. So the mass units cancel out. And that leaves us with 1 mole, because this is equivalent to one another, of C6H12O6. Now we can use the above conversion information. This is why we had to get to moles of the C6H12O6. And notice we have moles in the top, so we're going to have to put moles in the bottom. So we have 1 mole of C6H12O6 And on the top of this, we have 6 moles of carbon. So we've got moles here and moles here of the same compound, and those will cancel. And then in the last step, in order to get the last step, we've got to get to mass of carbon. And remember, if we go from moles to mass, we again go to the periodic table. So to do that last step, I'm going to hide where we're going for just a moment so we can do the last step. Then we're going to go to the periodic table, and at the periodic table, for every 1 mole of oxygen, there are 16 grams of oxygen. And note that the moles of oxygen cancels, one's on top, one's on bottom, and that's going to leave me with an answer that should have 3 sig figs, and so it'll be mass of oxygen. So I'm going to do that math really quickly. So 1.5 divided by 180.16 times 6 times 16, and I end up with 0.799, so 0.799 grams of oxygen. So I have the right sig figs. So just to recap, this first conversion, because it's mass to moles, is periodic table. We had to go get the molar mass. The second conversion is the chemical formula conversion, and that's where we looked at the actual substance itself and what we wanted to compare it to, how many was in there. And then the last one, to get from moles to grams, ended up being another periodic table conversion. So now what I want you to do is I want you to pause the video, and I want you to go to the next problem. So this will be problem number 2, and I want you to work this problem. So pause it, put pencil to paper, use your calculator, work that out. This is what is the mass of hydrogen in 1.5 grams of C6H12O6 instead of the oxygen. So I want you to go through that, pause the video now, work that problem, and when you're finished, bring it back on and make sure you have the right answer. I'm going to continue on, and I'm going to start with 1.50 grams of C6H12O6. We've got to convert that to moles, which we did on the previous page, so we'd have 180.16 grams of that compound per mole of that compound, C6H12O6. And then we go to the chemical formula composition. So note that for 1 mole of that whole compound, C6H12O6, what I want you to notice is for this whole compound, we have 12 moles of hydrogen. So 12 moles of hydrogen up top. So now we've got the mass of C6H12O6 canceled, and we have the moles canceled. And now we can go to mass, because if we stop right now, we would be in units of moles of hydrogen. And this is asking for mass of hydrogen in this compound. So we do one last conversion from mole to mass, and of course that's periodic table. So 1 mole of hydrogen per 1.01 grams of hydrogen. And that's going to be equal to, and this will also be 3 sig figs. So I'm going to look and see what that is. So 1.5 divided by 180.16 times 12 times 1.01, and that ends up being 0.101 is what I ended up getting. Now, I want you to go to the next problem, and I want you to attempt that next problem. So pause the video and try this problem. And notice it wants to know how many atoms, and this is oxygen, how many atoms of oxygen are in 1.5 grams. So notice it doesn't ask us to stop there. It's asking us to go all the way to atoms. So notice here, anytime you see atoms or molecules, that should remind you of Avogadro's conversion. And Avogadro's conversion is for every 1 mole of the substance, in this case it would be 1 mole of oxygen, there is equal to 6.022 times 10 to the 23rd atoms. Noting that you want to end in atoms of oxygen, you'll have to use this conversion. So you've got to get from mass of C6H12O6. You've got to compare it to the number of oxygens, so that means you've got to go to moles, and then you go to atoms. So I want you to pause and try that, and then come back after you're finished and see if you've got the work correct. I'm going to continue on working. So we start off with the 1.50 grams of C6H12O6. I know from previous two problems we did that the molar mass is 180.16 C6H12O6, that's per 1 mole. And we can now use, we've got our periodic table conversion. If we were to stop right now, we would be in moles of C6H12O6. We've got to get to moles of oxygen so that we can get to atoms of oxygen. So then I'll put for every 1 mole of this whole compound, so this is our chemical formula conversion. So for every 1 mole of C6H12O6, there are 6 moles of oxygen. If we stop right now, we're going to be in moles, and we've got to do this last step. And in this last step, we're going to use the Avogadro number conversion. So I want moles to cancel. I've got moles on the top. That means I've got to put moles on the bottom. So for 1 mole of oxygen, I would have 6.022 times 10 to the 23rd atoms of oxygen. Now my answer in this case will still have 3 sig figs, but it will be in terms of atoms of oxygen. So I'm going to do the math. So 1.5 divided by 180.16 times 6 times 6.022 EE to the 23rd. And I end up with 3.01 times 10 to the 22nd atoms. So my sig figs are correct. So at this point, make sure that if you missed points doing the conversion factors, to check those and go ahead and try to work those, and keep me posted on how you did.